Prompt engineers are getting paid 3 crore rupees in United States, and in India they are getting paid 17.5 lakh rupees on an average. What is a prompt engineer? Prompt engineer is basically a person who has art of talking to AI tools like ChatGPT, Midjourney, among others.
Say thanks to our management of Madanpalli Institute of Technology and Science, deemed to be university, Chancellor, Honorable Chancellor, respected Vice Chancellor, sir, the Department of Civil Engineering and all the faculties and colleagues and the participants also, as well as our resource persons from IIT Kharagpur, IIT Tirupati, NIT K Surathkal, NIT Patna, and even from University of Leeds, UK. Continuing with this, I want to give a little information that we in Civil Engineering Department of MITS Madanpalli, we are working on, we are looking forward for the exploration in the area of civil engineering, that how we can make more the overall process of civil engineering design and planning, design and the construction of civil engineering more and more sustainable and cost effective, as well as the time and resource saving. So looking towards this, our today's speaker, Dr. Dipankar Rao, which is also the head of Department of Civil Engineering, are going to explore, give the exploration in AI applications in civil engineering. Speaking about Dr. Dipankar Roy, he is a professor and head of the Civil Engineering Department of MITS Madanpalli, and is a visionary academician whose work bridges traditional civil engineering with cutting-edge AI technology. His leadership has been instrumental in shaping the department research culture, and today we will walk us through the evolving landscape of AI applications in civil engineering. From the predictive modeling to intelligent infrastructure system, let me give a warm welcome to Dr. Dipankar Roy. Sir, please welcome, and please take over this session and continue. Thank you very much.
Thank you, Dr. Jasawal, for introducing. And I welcome all the participants who have joined this 5-day FDP on the application of AI and ML in civil engineering, civil engineering field. So it's a very broad domain, and a lot of things are there to cover. But anyhow, first of all, I should thank the coordinators, Dr. Saifia, Dr. Vishal, and Dr. Nakiran, to organize this event and give a platform for everybody to join together and explore together the applications and future trends and where we want to be in future with this AI and application of AI. So let me share my slide. Before going there, let me just give a brief about my department. So the department was established in year 2014, and since then the department is doing pretty well. And we have a pool of faculty coming from various areas. For example, we have faculty coming from uh, northern part of India to Andaman Nicobar Islands to Maharashtra, UP. Like it's a very small department, but we have a total faculty of 13. But all of them are coming from various locations. We are very proud of our faculty and coming from various domains and as well as from various reputed institutions like IITs and IITs, foreign universities. And our students are also doing excellent. Uh, they are publishing papers like our UG students are publishing high impact factor research papers in different journals, as well as we have the startups in the department. Last year, there were 2 startups registered. This year, again, at the beginning of the academic year itself, we have registered 3 more startups. So we have a very good startup culture in our department, as well as a lot of patents are being registered. Starting last year itself, we had almost 30 patents registered in our department in the name of faculty as well as the students. So here is the brief about our department. So in the meantime, let me share my PPT. Am I audible?
Yes, sir.
Yeah, okay. So we start with AI in civil engineering. This presentation is aiming towards covering a broad aspect of civil engineering. It will not go much deeper into any particular domain so that I can cover most of the aspects. And of course, most of the aspects I cannot cover all because the possibilities are limitless. Only our imagination is the limit here. Because with AI, we can explore things that we could not have thought that we could do earlier. So let us start with it. So first slide, of course, it should come with what is AI, what we are trying to explore here. So AI is there are many various definitions exist. If you look at from the perspective of a computer science engineer, he will tell you a different story. If you look at some other person, they will also tell you a different story. It depends on who is using AI. So, but we can point to a single definition which is given which was given in format of 2017, the creation of intelligent machines and software that emulate cognitive systems for learning and problem solving. Now, AI is a very large domain, which large set inside which a lot of other things come. For example, machine learning, that's another set. It comes under that. And then inside the machine learning, which further generates the learning by itself, it is the deep learning. Then further deeper, where the AI starts to generate the things on their own. For example, LLMs, the ChatGPT that we're using today, we are asking questions. These are large language models. These LLMs try to understand our human words, and it will try to convert it to its machine words, and it will try to process all the information, and it's going to generate content. So here comes the generative AI. So before digging in further, let us see what is computing and knowing. Computing, as we know, like computing something. So that's it. So, but knowing is something where that is the key here. Because AI, when we talk about AI, there are thing called senses because we want AI to perform like human. Because otherwise, a simple Python program can also become AI, right? It's not. Because of what? Because it cannot do it something autonomously. But again, if we make something autonomous, can I call it out AI? It's not because I can give a set of instructions. It will continue to execute line by line, and we cannot call it AI. So we are trying to build a system which will try to emulate the activities of a human cognition level, right? So now here are 3 senses that are listed here. One is common sense, which you everybody know, which is of course not common every day. Then you have driving sense is something which is very interesting. A driver, when he drives a vehicle, so a lot of computation happens in his brain. So when you are going to overtake a truck, for example, on Indian roads, a massive amount of computation that you are going to do in your brain, it is overwhelming. So to do this for an AI, to train an AI on this one, it's not an easy task. It's a very difficult thing. And in the same line, if we talk about the design sense, now this one is related to civil engineers. How, let's say, in a village, you're going to construct a small house. So it's very common in our Indian villages that they do not go to some well-known structural engineer or something. They will simply go to the local mason. Local mason knows what is the design. So it's like knowing. He knows. He does not compute because he knows that okay, if I make this house, it will hold. It's not a problem. The reinforcement, that mason only will decide. The mix ratios, he will only decide without doing any particular computation. So here is the difference where AI is not able to overtake yet, because human has human level cognition which AI cannot overtake. So this is a very interesting picture. It is a very old picture from a newspaper. It's an accountant who is, the title of the picture which was printed on the newspaper was that the accountant is he's finishing his day and he's settling his accounts, and this is the abacus it was used. And you can say interesting fact is that people, those are looking at this abacus from outside the window, and they're curious, uh, how curiously they are looking at it. This sums up the whole thing. The future belongs to those who embrace the technology. So we can say that yes, AI cannot take our jobs and all. Lot of discussion is there on that one. But the thing is that, but AI we cannot avoid. We have to embrace AI. Then how do we do that? So that is the basically I'm trying to set the stage that whatever we are going to discuss, a lot of things are there, a lot of questions, a lot of uh, things are there, a lot of things will be discussed. But anyway, this is basically setting the stage. Now we are here, math, engineering, and AI. Where we are? We're at the level 2. That means we know maths, we know exact analysis. We can do, for example, calculate the stress on a beam. And now using the maths, we can calculate. But when we come to engineering, and that's why we say that engineering, it's more not math, because engineering to make the numbers such a way that finally it is suitable for the real world conditions, and finally we arrive at a solution or design which is fitting to the real world needs. Now obviously maths and engineering, we have seen that. Now what is AI? Now what is the third level? AI is probabilistic and rounded. So AI does not care about math, AI does not care about engineering. Everything is number for AI, everything is data, and that data has no meaning for AI. So AI, what it will do? It will suggest a beam design directly by recognizing the patterns from existing datasets. It has nothing to do with maths or engineering. So here comes a problem. The trust factor comes here, because can we totally trust the AI? At this point, no. But coming the days when obviously this trust will build up slowly and we'll move on. So by the time we're discussing all these things, trying to get acquainted with AI, there are many companies who have already understood the needs and they have already moved on. These are list of companies who are incorporating AI at various levels to make their software faster and more intelligent at various stages of a project lifecycle. For example, planning and programming, during the schema and design, we have the design during the design of development. Hyper is there, Augmenta is there. During construction documentation, we have softwares. For bidding and negotiation, softwares are there. Nowadays, bidding becomes easy, negotiation becomes easy because we have a lot of research. We have ready data. We just ask AI, and obviously, it's not yet fully developed, but yes, things are going on where bidding and negotiation becomes more and more convenient. Then during the construction phase, there are several companies which are incorporating AI. Then after post construction also, there are several softwares which are taking care of the entire heavy lift. Heavy lifting. Now LLMs, you all know what is LLM, right? It's a large language models. Basically, it's a chat GPT is based on that. What it does, it is trained on a large amount of data set using a very strong GPU is trained, and finally using the trained data, when we ask questions, it will give us reply, and that human like reply summary. And with the release of GPT-5, it has become even more efficient. Now, in the meantime, you see, ChatGPT is a very generic model, so it will talk about everything. But for structural engineers or civil engineers, for example, this slide is about structural engineering. So we have structural GPT, Singularity Civil and Structural Engineering. These are the GPTs specifically designed for answering questions related to this structural engineering pro or structural engineering, college structural engineering. So people are trying to take the GPT as a base, and they are trying to train the GPT with their own data set to make that very intelligent and smart in that particular domain. So that ask the AI, ask that particular model a lot of questions, and that those question answers will be very much linked to those data sets which you have trained that model for with. So now all of you know about this notebook LM, right? So what it does, Google's released that, and you can upload a lot of documents and you can ask questions. It will basically research from those questions, and it is going to answer. Now, here is the interesting thing. This is the structural engineering GPT, and with GPT-5, you can see at the top left corner, structural engineering GPT. It actually solves a lot of problems here. And you see, these are some sample questions. What are the best materials for an earthquake-resistant building or something? And how do I calculate the load-bearing capacity of whatever? That is up to you. Can you explain the principle of tensions and whatever? See, this is the things. Now, GPT, as you know, the Sam Altman said that they are working on GPT model, which is going to read your brain. Basically, without asking, it is going to answer your questions. I don't know how that is going to happen because it's very strange, but people are working on that. It is very, very incredible even to think that you are thinking about something and it's just going to answer the question, right? And then going forward to the next one, you see HydroGPT. Now, HydroGPT claims itself as expert in water resource engineering, which is specializing in hydrology, hydraulics, and drainage design. It provides detailed assistance in modeling, concepts, methodologies, and scope of work. So you see, reporting, etc., everything it does. And you see what kind of questions you can ask. What is the land use type you can see in this image? Just upload an image and ask that just classify the image or maybe do whatever. Like regular people who are working in the hydrological domain, we do this all these times, and we know how much computational work is involved in this kind of things. So now we have this HydroGPT. It is an expert in that. You just simply upload an image, it will tell you because it has been trained on large amount of data set, large amount of images, and it already knows what are the signatures mean. And probably it will be able to give you the forecast also. Maybe it can tell you if you give a time series of photographs, images, it will tell you what is the forecast, etc. I don't know. The possibilities are endless. And with GPTs evolving, these are getting more and more smart. Just think about GPT-4, 3.5, 4, and 5. There was a massive increase in computational capability. Then going forward, design and planning. How the AI does the work. Here, heuristic search-based designs are like biologically inspired methods like genetic algorithms, particle swarm optimization, cellular automata. These are used for heuristic search-based designs. Now, growth-based designs. Now, this particular design is relied on. It will start from a certain element, and that will keep on growing. And while growing, it will look at different constraints, environmental constraints, cost constraints, or safety constraints, or I don't know, many other, whatever possible constraints, or regulation constraints, everything it will check, and it is going to improve, and it is going to keep on adding. So this is growth-based designs, which this particular algorithm does. Then generative AI. This is the next level AI, which it surpasses every classical methods by learning from the design data and rapidly generating efficient new designs. So basically, this generative AI, as you see that with the generative AIs, there is a huge boom of generative AI nowadays. Everybody is using it without even knowing that they're doing it. So generative AI in construction. So how we use it? First of all, we have the ground truth data on the left hand side. Then we have a set of neural network. Basically, it's a generator. Which generator will be using the physical constraints. There is an input layer and there is an output layer. So after we get the output, that output will be further sent to evaluation. That now the discriminators that is going to identify based on the ground truth data, which are real data and which are fake data, or maybe the simulated data. So it is going to discard those things. And again, knowledge embedded loss functions like physical loss or empirical loss or statistical loss, all these things will be considered, and finally it will arrive at a final design. So all these images are taken from research articles. And now here is the interesting thing, the prompting. You all of you know that GPT works on prompt, right? Now, how do you prompt depends. I mean, it decides like how the output will be. For example, forward prompting and backward prompting. First of all, if you have the goal in mind, and if you ask the AI to do this, it will arrive at a design. Now go backwards. You give the design and you ask that what is the analysis of this? Or maybe what are the optimization tweaks I can do? For example, the right hand side, you can see that if I ask a chat GPT or maybe the structured GPT that design a lightweight pedestrian bridge with a 30-meter span using steel and concrete, optimized for minimal material use while meeting the safety standards. Okay, so I have asked everything. So it is going to design a 30-meter span pedestrian bridge, and it is going to find out the minimal material use while meeting the safety standards. Then it will arrive at the design. But now go back, means you give the design and you ask that analyze this truss bridge and explain how its load paths are distributed and suggest how the material usage could be reduced without compromising safety. Now, if as a regular human engineer is trying to work on this, there will be a lot of constraints. It is highly time taking. You have to work on different materials and redo the same thing, trial and error, and find out that how many iterations you have to do. And finally, you may or may not arrive at an optimal design also. But AI, it has no computational limit. It will keep on doing until it arrives at a final number, right? So final design. So that is a very interesting thing. Now, that's why, now how do we do this? Now you see, you have the ground truth data, existing data, everything is there. Now suppose you want to design, like you have general softwares, like here I'm taking example of e-tabs. Suppose you are generating some data using e-tabs. You design based on certain conditions and come arrive at a design using e-tabs. Now this design you give a as an input to the model, and you train that model using this e-tabs data. Now of course you are going to use lot of data, like lot of iterations you're going to do. All this data you're going to supply to this model. Now this AI model is ready with this training data, right? Now AI model is going to supplement everything that you're going to do. So now basically ETABS generates data and then AI learns from it, and then AI is going to assist you to help assist you to get this thing done in new projects that too using the ETABS only. Now, how does it work? So these softwares are coming up with different functionality, like if you try to select some material or maybe some dimensions, it is going to prompt you. It's not optimized design. So you are stopped at the beginning itself. So you see the future, how we are moving. So right now, whatever you are doing, you have to arrive at the last stage to find out that find that whether this is good or bad. So, but at the beginning stage itself, the AI is going to identify whether your input is not right or wrong. So it is going to suggest you. So based on the suggestion, you change your input and you arrive at a final design. And of course, it is going to be much more efficient. You see. So at this point, we are not talking about that AI is going to do the whole design. No, not at all. Right now, trust factor is the problem. So we do not trust the AI designs at all. So engineer is going to do the design, but AI is going to prompt. So you see how faster a engineer can grow and complete the design. So client requirements, ever demanding clients, they will always tell that I need faster, faster, faster. But okay, if they have changed some things and you can arrive at the solution or design very quickly. So that is the a huge thing we can achieve. Now, if we look at the, okay, fine, we are talking about the training the model using our data, right? How do we get the data? So public domain data, we already know that a lot of government research, open source documents are available. We can use the public domain data, and then collaborative data shared across groups, industries, and communities where shareable data is available. Organizational data, it is a problem because organization has their own data and they will not share. So they will be keeping for their own. So now what I am thinking that probably uh, they are going to make their own models basically in because a particular suppose a large construction company is there, they have a huge set of data because they have undergone multiple projects and they have massive amount of data. Now they are going to have their own model, train their own model with their own data, have some extra data from the open data sets, and they're going to have a very nice gpt of their own. So you see a lot of advantages. So now then individual knowledge is also there. For example, the person who is executing it, that person also can add his own data. And now comes to the generated data, because if all this data is not enough, then you have the generated data. Use the synthetic data that you are generating using different structural softwares and go for it. So this is the source of data. Construction management, here comes like it's a ocean, because project life cycle, this is a huge thing, and AI excels in it because AI is basically built for this kind of task only. But truth is that in Indian construction industry, it is not yet implemented, or of course, it takes time because people are not yet mentally ready to go forward. We know that a lot of cost, the majority of the project cost goes to the indirect cost. Direct cost is considerably less, but indirect costs are very high. So that part, if we can reduce, it can reduce the project cost drastically, and then there is sustainable construction also. Now, if we see the construction management, robotics and automation, that's an option. Quality control, it's a very great thing that AI can do. AI can optimize. Now it's a business insight. Like this is a Fortune Business Insights. They have released one research, a review basically on the global AI trend in construction market. We are very much behind the global market even now. You see, North America is leading, obviously. In 2024, it is 3.93, and we are looking at 22.68 uh, billion dollar by year 2032 with a CAGR of 24.6%. That's a huge growth, and it's not just the forecast. We can understand, we can feel what AI is going to do in this particular industry, construction industry. North America, they have 1.24 billion now, and they are going to search to, in 24 it was 1.53, and South America, Europe, and they are all trailing. But of course, there is a huge potential for Asia Pacific region because infrastructural growth is definitely needed in these areas. Then we can see that drivers. What is driving this AI adoption? Constant need for improved efficiency and productivity in construction industry. And if you look at the solution, what are the different solutions they're providing? Majorly, supply chain management, one of the leading sector where this AI is really doing well, and already it is implemented. Risk management is one more factor where it is really doing extremely well and being implemented worldwide. And then schedule management, project management, and many other solutions they are doing. But here is a SAP AC. This is a German company who are very much good at the supply chain management. They have unveiled advancements in this supply chain solutions, which are poised to surge manufacturing productivity, efficiency, and accuracy. So this is a big deal. So now let us look at some numbers. So AI software market, what is the AI softwares, whatever we are using in this construction technology area, it is set to surge from USD 64 billion to 251 billion by 2027. That's a huge jump. That is a CAGR of 31.4%. And similarly, the generative AI platforms, these are estimated to generate USD 55.7 billion. That's a big number. We are looking at a AI blast, basically. Therefore, generative AI transforms the construction industry by revolutionizing design, creativity, process optimization, and risk management, leading to more efficient, sustainable, and cost-effective construction sites. Now, here, this number 49%, that's a worrying thing. Industry experts suggested that AI could automate up to 49% construction task. Now you see this is a construction area is human resource heavy. Lot of workers are required. So all the workers can be uh, replaced by AI here. Not all 50%, almost close to 50% of them can be replaced here. But here in India, scenario is little bit different. In 2023 survey, is not very recent survey, but survey gives some number. Like 38% of Indian companies, they had no plans to adopt digital technologies. That was in 2023. But AI boom happened now. I'm sure this number has reduced, and almost everybody is looking at AI expansion towards AI using AI, because if they do not adapt, they cannot survive. That is the situation now. Now, these are some companies, if you see that these are the list of top companies, AI companies, which are adapting AI for giving intelligent solutions. Autodesk, all of us know because it's for product every civil engineer uses. SAP SE, that is the German product. Bentley Systems, again, Statpro and all these things. We all use this kind of software. Alice does all systems. Oracle Corporations, Japan, Doxel from US, all of them are leading the market for adapting the AI in construction sector. So world is already moving on. So next area is the structural health monitoring. So that's a sector where huge possibilities there for implementing this AI. So already there is a explosion in the urbanization, smart infrastructure and assets are aging up slowly, and safety rules are changing. It is becoming stringent day by day. So obviously we need to meet a lot of demands. So obviously all the old infrastructure need to be monitored, and it has to be repaired on time. So real-time anomaly detection and remote monitoring becomes the need of the hour. So obviously we cannot do that on our own. So we need the technology to help us. So North America is currently leading the market share, but Asia Pacific is on fire. So it is going to be the fastest growth due to aggressive infra investments and urban mega projects. That is the story of the Asia Pacific region. So again, some numbers just to see that how the AI is growing. In March 2025, 75 studies were done. It was found that 90% accuracy was found in ML, which outperforms all remaining methods. IoT sensors are used regularly. These cut the data collection time by 65%, and the inspection speed is going up to almost 85%. That's a massive number. Blockchain technology ensures the data integrity, reducing breach risk by 65%. Maintenance cost is down. Then obviously in every sector it is performing excellent. So this is again the world map where you can see that there is a growth rate is the highest in the Asia Pacific region for this SHM area. So going forward, this is the projection graph for India. So you can see from 146 billion to 78 million. Sorry, it's in millions. So the market is going in that direction. Now coming to sustainable construction. So AI in sustainable construction and doing excellent job. There are studies where it was seen that the AI is able to design SCM rich mixes without even going for lab test or anything, and it can finally lead to reduction of clinker and embodied CO2 while meeting the strength and curing targets. So this was incredible find. So obviously the deployment also happened in 2025 itself. The deployment was seen. So then LLM based embodied carbon automation, like it is emerging. Then beam or specifications to map quantities to EPDs, environmental product disclosures and databases, cutting life cycle assessment time, and surfacing lower carbon alternatives early in design. So this is what is happening. So sustainable construction always our focus is at lowering the carbon emission. Now integrated beam AI workflows. So beam the Revit is again it is incorporating AI heavily in the BIM. So all the softwares are getting very smart and intelligent day by day. So integrated BIM AI workflow supports generative and multi-objective sustainable design and tighter carbon-aware decision loops across concepts to detailing, as highlighted in the recent reviews and industry guides. So a lot of things are happening. So again, AI is reducing the construction phase waste and emissions. So we can actually monitor the entire project site by drones, and also we can continuously, suppose you have the CCTV cameras, you can use the computer vision to analyze what is going on in the whole project site. So we can actually reduce the project this construction phase waste to a great extent, and logistics optimization is highly possible with this application. Then carbon accounting platforms are there, and these are actually adding AI for automated this scope 1 to 3 tracking. So the factor matching, anomaly detection, everything is there offering this carbon accounting platforms. So this is a image where you can see that the sustainable construction concept in a global context. So traditionally what we had was we used to think about only cost, quality and time. And we used to think that, okay, fine, uh, this is a success. For example, you are going to design a metro station, and if you are reducing the cost, quality is also fine, and you are doing it 2 to 3 months early, you are happy that yes, my project is successful. It is a construction is good and it is done. But we are into the new paradigm where we can see that in the new paradigm we have the environment in picture, where we are conserving the natural areas and biodiversity. This is a situation, and this is definitely a constraint. Reduce harmful emissions and maintain healthy environments and minimize depletion of resources. So these are the things which are coming in with the sustainable construction. Now, uh, hold on, I think some network issue on my. Just give me a moment. I think network issue on my side. Yeah, hello. Some issue with the network. I'm trying to connect my PPT again. Okay, sorry for the disruption. There was I think I'm audible now.
Yes, sir.
Oh, right. So, so this is a 95-story skyscraper in London. So this was also made using this digital twin technology to optimize its energy usage and to reduce its carbon footprint. So the next domain that comes, there is the traffic and transportation. I think right now everywhere you see this AI is being used in traffic management almost everywhere. Around the world, it is very common. Even in Indian cities like in Pune, in Bangalore, everywhere. I think in Kolkata also for the traffic congestion, ease of traffic congestion, this transportation, this AI technology is being used. Now, this AI-driven monitoring and prediction, this is the one of the very common, uh, usage of this AI in this area. Then intelligent signal control already is being happening even in India also. Then going forward, this network-wide optimization. So this is dynamic rerouting and AI-informed congestion pricing balance across the corridors and times of day. So basically, it is going to reroute you dynamically to just to reduce the optimize the whole travel. So this is a image where you can see this is a cooperative vehicle infrastructure systems, which is V2X, vehicle to everything. So these communications are happening between vehicle to the signals, vehicle to this traffic signals, to everything. And the camera and analytics, everything is being done at the same time to analyze the whole thing. And the messaging is done where a particular device is continuously sending the messages like a heartbeat 10 times per second or so to a vehicle that yes, I'm there, I'm there, like how you know the GPS signals work, similar way. And then there are environment aware messages which are being sent to the vehicles. So it is paving the way of incorporating this autonomous vehicles on the road. Right now, autonomous vehicle on the Indian system is not feasible, but of course, days are near when it's going to happen. So, traffic and transportation engineering under this one, see, this particular emerging fonts turns into the generative AI for scenario synthesis. Now, thing is that we need to train a particular system with a lot of data. Now we do not have access to such kind of data. Now how do we get the data? So here comes the generative AI. Generative AI is going to generate so many situations, and it is going to feed it to the model. So basically, for example, you are going to drive a car on the road, and suddenly a certain person comes in front of you. So you are not able to test this on road because nobody is going to volunteer to come in front of an autonomous vehicle for obvious reasons. But a generative AI gives us a possibility to generate the entire scenario and not involving the actual human. And this data that is going to come out from the particular generative AI is going to be fed into the model so that this model is made more robust using this kind of data. So this is a very interesting thing that is emerging. So these are again these are old news. Transportation launches 15 million AI effort to improve US street run infrastructure. So it's everywhere. It's not just here. So it's Goa, used from Goa in 2023, 2 years back itself, Goa implemented e-challan system using this AI-driven technology. And then next area obviously comes to the water management, the next sector, which AI is having a huge impact is this. So AI is transforming forecasting, monitoring, and management of water systems. So we are talking about smart cities. There, we are going to find out that what is the water demand, how much, from where, like optimizing a water resource in a city is not a simple task, and AI is doing that very nicely. Key drivers why we need to use AI. That is, reason is climate change, urbanization, and data from satellite and sensors. Then, what are the core tools? uh, Machine learning, ML, and deep learning, and physics informed models. Now, physics informed models are some things which are AI models, which are also taking the physics in consideration. So that comes as a parameter, the physics. Now, what are the different major applications that we see in the water management area? It is flood and stream flow forecasting. So in recent days, this particular flood and stream forecasting becomes much more accurate and much more faster with AI, involvement of AI. Now, soil moisture and drought monitoring, it becomes again very quick and easy because we have the satellite imageries coming in from every various satellites, and we are using the ML. Using these two together, we are going to arrive at the drought monitoring at a very easy way. Then groundwater and water quality monitoring, and when there is a large amount of data and AI is there, anomaly detection and predictive modeling becomes very simple with this. And smart management of reservoir operation and leakage detection, demand forecasting, these are also the ways where we can implement the AI. Now, geospatial artificial intelligence, also called Geo-AI. So this is another area where this particular Geo-AI allows the harnessing of big and high-dimensional data to better understand hydrological processes. So we all know about hydrological processes, how it occurs, and it's stochastic in nature. Every parameter affects each other, and it's very difficult to model all of them. So here is this is an area where this AI can do excellent. So geospatial artificial intelligence, Geo-AI is already there, and it is already doing its work in this area. A lot of people are working in this area. Now, GIS and AI, next area. GIS, already we know that
only sparked the curiosity on us, but also provided the practical direction for the integrating intelligence system into academics and research practices. So our deep appreciation and thanks for your time and effort. Moving further, there is a little small instructions for the participants that I'm requesting the participants to please give your attendance through the link which has been shared in the chat box. Please give your response. It will be taken as an attendance, and you have to give your attendance on every session twice, so that we can understand your presence, and then it will be easier for us to deliver the final certification when we complete the session. Further, 80% attendance is required, and I request all of you to please attend 5 minutes early, so that it will be easier for us for the easy execution of the session. I encourage the participants to please open up and ask more and more questions, so that we can also understand that this session is interesting for all of us, and we will be also motivated. With that, I thanks to our resource person, Dr. Dipankar Roy. I thanks to the management, the the chancellor and the vice chancellor, and all other management from MITS Madanpalli for giving their continuous support for the execution of this session, FDP. And as well as I thanks to Department of Civil Engineering of MITS Madanpalli for their continuous support for the execution of this session. Last but not the least, thanks to the participants who have shown their interest in these sessions and registered and participated. Thank you very much. So this is Dr. Swapnil Jaiswal, Professor MITS Madanpalli, thanking you, and closing of the session. Shall we disperse? Dr. Roy.
Yeah.
Yeah.
So thank you all.
Thank you very
all the
much all.
participants.
Thank you.